Hi, let's solve today's daily challenge, that is find bottom left tree value. In this question, we're given the root and we have to return the leftmost value in the last row of the tree. Again, a very straightforward question. So we know what we have to do. We have to take the leftmost value of what? The last row of the tree. So if you see this particular tree, what is the last row? You can see this is the first row, second row, and the second row is the last row. Inside of this last row, you have to return what is the leftmost value you have. So that is 1. So you'll return 1 in this case. Now look at the second tree. Here, see, we don't have to print the leftmost value of the tree, rather leftmost value of the last row. So in this case, if you print 4, that would be wrong because you have the last row as this, right? Let me show you. So here you see this is the tree given to us. This is the first row, second row, third row, and the fourth row. And this is the last row, correct? So 4 would be a wrong answer. We don't have to print the leftmost node. Rather, we have to print the leftmost node of what? The last row of the tree. So here in this case, the answer would be 7. Correct. So as soon as you see, I have rows, right? I have rows. So basically, we are trying to compute something in levels, right? In levels. So as soon as I hear the word level, right, one word should click to me then and there is BFS, right? So BFS is what breadth first search. So BFS is what breadth first search, and it is also called level order traversal, right? So when we do a BFS traversal, right, we basically try to go in levels. Now how do we achieve that in BFS? We use a queue data structure, right? So inside of the queue data structure, what we do is we first priority is to like push the root node, right? After we have the root node, you take out this root node and you push the left and right child of these two nodes, right? Sorry, the node that you have taken out of the queue. So you push 2 and 3, and then what you do, you then check for 2. Now see, this is your whole level, right? After you pop this, you simply take the size of the queue and you iterate inside of that size, right? So whatever is the size, you take out those elements within that iteration. So we have 2 3, right? So 2 3 are within one level, correct? So when we pop out 1, right, we would have already pushed 2 and 3 inside of the queue, and then in the next iteration I have to take the size of the queue, right? Take the size of the queue. So that is 2. That means I have to pop 2 elements, right? So first I'll pop 2, and for 2 I'll push its left and right child. So that is 4 only, and for 3 it is 5 and 6. So I'll push 5 and 6. So after I have checked for 2, pop it out, check for 3, pop it out. Now you can again see 4 5 6. This is the next level, correct? So this is how we do BFS traversal. Now you can see that why it is called level order traversal, because we are iterating in levels only. Now what we can do is we can do a normal BFS traversal in this question, and we can save the values of these levels. We can take an 2D array. Inside the 2D array, I'll simply push the first level, the second level, the third level, and the fourth level. And what I'll do is from the backside, right, from the will iterate that vector, right? So see, inside of that array, it would be stored like this: 2 3, and then 4 5 6, and then 7. And then what I'll do is I'll iterate it from the back, and I'll just take the n minus 1th vector from this and take its first value, right? So I can simply take, let's say this is v, let's call it level. Okay, so we have levels of n minus 1, whatever is the size, comma 0. It's going to return me the leftmost. But here, if you see, if you use this approach, right, you are going to consume some extra space, right? So can we reduce this, right? So yes, we can. We can simply modify the traditional BFS. See, in traditional BFS, what we do is we take the left child first and then the right child, right? So we push the left child and the right child. Now, if you see, an interesting thing about this BFS, that when you're pushing left child, right child, left child, right child, left child, right child, so it's like left to right manner, you'll get all your nodes inside of a BFS. See, you have one is, that's all right. So if you have two, because you are using left to right BFS, correct? So you have two. then you have 3. So inside of your BFS, see what is there, 2 and 3. So it's in left to right manner, like this. Similarly, 4, 5, 6. When we did BFS, right? See what we have, 4, 5, 6, right? So in left to right manner. So if I just change this manner to right to left, what would happen is, instead of pushing the left child first, right, I'll push the right child first. Okay, so if I'm pushing the right child first, see what will happen. If I'm pushing the right child, okay, so first obviously 1 will be there, then you'll push the right of 1. What is it, 3? Then you'll push the left. Okay, pop this out. Then you have this particular level. Right now, pop out 3 and push the right first, right? So right is 5 and 6, correct? 6 and 5, correct? And then for 2 there is only one node, so push 4. All right, pop this 2. Now you see, you are having in this order, we had 3, 2, 6, 5, 4, right? And then you'll push 7, correct? So you remove this. So in the last, so what you just save the last node of the BFS traversal, right? The last thing that you pop out from the BFS is going to be what? Your leftmost node of the last row, right? So that is what we want to print, right? You can see here. Now let me show you for, let's say I have an 8 here also, okay? Let's say I have an 8. So in the last level, here we only had 7, right? So that's why it might be confusing. But see, we had a 7. So for 6, you don't have anything, right? This is not nothing. For 5, you have something, right? So push the right first and then the left. So here now you can see the distinction, right? The distinction I'm talking about, that you will definitely have the last row, but the last node of the queue, right? The just before your queue becomes empty, right? That node is going to be your leftmost node of the last row. So this is the basic approach for this question, and this is what we are going to use. Now see, we are not consuming any extra space than this queue, right? So the space complexity will be big O of n. And talking about the time complexity, obviously it's a BFS traversal, so it's going to be big O of n as well. Now Q has to be used. We cannot reduce the space complexity, okay? So this is the time and space complexity for this particular question. Now let us go ahead and see this in code. See, here, what I have done is, first I declared the queue, right? After we declare the queue, you push the root of the queue. Then you iterate inside of the queue until the queue is not empty. So inside of root, you are storing the front value of the queue, right? What you are doing is store the front value of the queue. Then if a right, see, we are first pushing the right and the left. Why? Because we are doing a right to left BFS traversal. So in right to left BFS traversal, you first take the right values inside of the queue and then the left values. So then you are taking the left values. Now what will happen is, just before your queue becomes empty, right, you will store the last node of this queue inside of the root. Correct. So inside of the root, in this particular case, you'll be storing 7. So here you can simply return the value at this particular node. In this case, what you'll do? In this case, you will store 1. So that is what you'll return, right? So inside of root, you are going to have the last node of the traversal. And that is your answer. That is the leftmost value in the last row of the tree. So I hope you understand this question. This is the basic approach and how you have to solve the question.